y equals sine x, where x is measured in radians, we're asked to differentiate from first principles to obtain cos x. Now we can quote the formula for differentiation from first principles. I'm actually just going to very quickly talk about where it comes from. So if I just draw a little graph of a general function, then what we're doing is we're picking a point on it with coordinates x, and the y coordinate will therefore be f of x. And then another point a little bit further along, x plus h. I can control h, make it big, make it smaller, which we're going to be doing in a second. And this will have f of x plus h as its y value. Connect them up. The gradient will be rise over run. F of x plus h minus f of x is the rise. It's the difference between these two. And then I'll be divided by h. And that's actually my gradient, delta y over delta x. And my answer would be in terms of h at the end of it. So what we then do is just move the point closer and closer to the original point, technically never having it exactly on top because then you'd be divided by 0. We instead use an idea which we don't go into lots of detail on, but a limit as h approaches 0 of this gradient, and that is what dy by dx is, the instantaneous gradient at a point. So for us, we've got f of x equal to sine x, and therefore we need f of x plus h, which is going to be sine x plus h. And we're allowed to use without proof the formula for sine a plus or minus b. So we want the plus version. Okay. So it's going to be sine x cos h plus cos x sine h. And I'm going to go straight into it, I think. So therefore dy by dx will equal sine, wait, I forgot about the limits. Limits as h approaches 0 of this minus sine x, of course, the original function, all divided by h. Don't forget we can quote some values later on, just bear them in mind. I'll talk a bit more about them. Right, now first up I'm going to combine these two terms, or factorize out the sine x. So I'll be left with cos h minus 1 sine x plus sine h cos x all over h. I didn't want to do it all too fast because we need to be really clear with our working. And now with my limit, I can split it into two different limits, and also I can rewrite the first bit as cos h minus 1 over h sine x. Then it'll be plus the limit h tends to 0 of sine h over h cos x. They're exactly the same. And what we can see is that this one tends to 1, just that bit there, approaches 1, whilst this one here approaches 0. And so essentially this cancels out, and we're just going to be left with cos x. Because I've got 0 on the left, I've just got 1 times cos x on the right. We get as our final answer cos x. And we're done. Just very quickly, let's just talk about where that actually came from, because it all comes from the small angle approximation. Sine x is equal to x minus x cubed. You don't always go into detail on this in A-level maths, but I'm going to. Actually, an infinite series. So for small x, apply sine x is going to be approximately just the first term, x. And therefore, if we have something like sine x over x, then that will be approximately 1 for small x. Haven't really gone into the limits here, but yeah, as x approaches 0, sine x over x approaches 1. Whilst for cos x, it's 1 minus x squared over 2 factorial, it's x to the 4 over 4 factorial, etc. So for small x, we get 1 minus x squared over 2. That's what we typically, that's seen in the formula book. And then if we have cos x minus 1 over x, then this is going to be approximately 1 minus x squared over 2 minus 1 over x. These two cancel, and I'm just going to get minus x over 2. And so when x gets small, as x approaches 0, cos x minus 1 over x will also approach 0, because this thing is just going to get smaller and smaller as well. So that's just a little bit of background away from the question where those things came from. We're not expected to quote all of, do all of that. We can just quote these results, but please be aware of them because they're at the heart of this derivation. Okay, well done. One to practice and just make sure you're familiar with. The same with differentiating cos, very similar approach to get to minus sign. But yeah, that's it.